Well, Joy, in this video, we're going to look at how to make smarter parts in Solid Edge using parametric design. So in previous videos, we've kind of gone through the process of creating this part, and we also named some of our variables or parameters. So if I go to the Tools menu, select Variables, we gave a name to variables like the block depth, the block length, the block height. They're all things that could change in our part. So if I update that to 22, you can see that the length changes. Let's change it back to 15.8. Hit enter. So we made it so all of those could be updated. And now we want to actually make things a little bit smarter. There's other parameters that we may need to change too. Also, the way variables are listed in our variable table isn't particularly helpful. And as models get more complicated, sometimes it's more useful to use the structured view. So if we select that, now we see all of the features in our Pathfinder listed, and we can expand each of the features to see what variables or parameters are associated with them. And that can be very, very useful, very helpful in just making things more manageable. So we kind of said already, we can update the length of the block. It isn't particularly helpful to change manually from 15.8 to 23.8. It's still a very manual process and not very helpful. So we want to make that a little bit smarter. Also, our pattern here has two variables, and let's just take a look at those variables now. So this, we have 2. Let's just change that 2 to a 3 and hit enter. And now that's interesting. So the number of pegs on our block has changed to 3 in that direction. I'll just change it back to 2, and our other variable, our other parameter, I changed that from 2 to 3, and we get 3 in this direction. So that's kind of very interesting. So it looks like a variable that we could actually use. I'm going to turn on our base reference plane just to get our coordinate system displaying. So here's our x direction. And if I press 3 there, yeah, we get 3. So I'm going to call that variable there nx peg. And for the other variable, I'm going to call that ny peg count. So that's still not very exciting. It's something, but it's not really very exciting. We notice in these parts, there is a kind of a standardized system. If we go into PMI and create smart dimensions in PMI, I can go from the edge of the part to our first peg, and that is 3.9 millimeters. And the distance between pegs should be 8 millimeters. And then between the last peg and the face of the part is again 3.9 millimeters. If we look at our part from the top, there is our PMI giving the spacing we should be having on these parts. So that is a very set format for these. And because of that, we could create a formula for the length of our block based on the number of pegs we want the block to have. So our block length, we can control that with a formula. So for the block length, I'm going to click in the formula box here on our variable table, and I'm going to press equals 2 multiplied by 3.9. So that's 3.9 millimeter either end, plus 8 multiplied by, this is our block spacing. And I'm opening a bracket, and I'm just going to choose nx peg count. I'm going to click on this variable here, and I'm going to press -1 and close the bracket. So let's just press enter there, and you'll notice the value here hasn't changed, but the box has. We've gone from a white box with a lock beside it to a grey box with no lock. And that's because this is no longer a driving dimension, it's a driven dimension, and its value is controlled by the variable nx peg count down here in this formula. So let's just take a look at what that actually means in practice. If I go over here and if I change nx peg count from 2 to 3, the length of our block now changes. It's driven by the nx peg count variable. So our block is now 23.8 millimeters. If I change it to 4, it goes to 31.8 millimeters. Our pegs haven't really updated correctly, but the number of pegs has. So we've gone from 2 pegs to 4 pegs, but they haven't really spaced correctly. The spacing should remain 8 millimeters between pegs, but that's something we can fix now. So maybe let's just change our nx peg count back to 2, back to where we started. And we can go to, I'm just going to get out of our smart dimension, go to home and select. And if I click on the pattern feature here and click edit profile, the sketch profile for our pattern appears. And let me just hide the PMI. So this is our sketch pattern. And you'll notice we have a rectangle, or a square in this case, and we have this heavy, bold black X in the corner. That represents the parent feature of our pattern. And you can see it there if I move a little bit off 90 degrees. So we can just take a look at this, maybe put in some smart dimensions here. So if I go from this edge of our pattern to the edge of our part, that's 3.9 millimeters. You'll notice that that's like a blue dimension. And if I create another one from here to the edge here, that's also 3.9 millimeters and a blue dimension. Let's just select these blue dimensions. And you see this is a driven dimension. And click here, this is a driven dimension. And what that means is this dimension doesn't control the position of this line. This dimension just kind of reports back what the distance of this line from that face is. And the reason for that is that the position of the line is already constrained. It's already fully defined by the software. And that's because this pattern is based on the peg feature. It's locked to it. Okay, so I'm going to create more smart dimensions here. So I'll create one from the edge of this rectangle to the edge of our part. Click, and 3.9 is the correct value we want. So I just hit enter, and you notice that a red dimension was made. This is a driving dimension. And do the same again for here. 3.9 millimeters, another driving dimension, and our sketch has become fully constrained. Okay, so I can click here to exit that sketch, and now our X count is 2 and our Y count is 2. Let's try updating our X count again. So I'm going to change it from 2 to 3. Hit enter. It didn't quite update as I would have liked, but let's just investigate that again. So I click on pattern, click on edit profile. Okay, so actually our pattern isn't locked in like I hoped. It looks like it has kind of broken away from where we would want it. And it looks like it has kind of made itself symmetrical about the origin. I'm not sure why, but let's fix that. So I'm going to choose this project to sketch, select the top face of our part and accept that. So now I'm going to use the connect button, get the base point of our pattern feature. I'm going to hover over this circle until the center mark of it appears. And I'm going to go over to the center mark and click on that. And now we have locked our pattern feature back into this base feature. Also, for some reason, our 3.9 changed to 7.9. So I'm going to change that back to 3.9 like it should be and press enter. Now we have a fully constrained sketch. I'm going to exit out of that sketch. And now pattern our pattern updates and it looks pretty good. So I'm just going to rename that while we're in here. So I'm going to call this peg pattern 1 and I'm going to click on the finish button. And if I turn on the PMI, you see here the dimension between these two pegs is 8, 8, and then 3.9, 3.9, 3.9. And we've kind of jumped a peg now because we've created an extra one. So if I go into PMI, smart dimension, 8 millimeters between these two pegs, and from this peg to the end of the part is 3.9 as we'd expected. Okay, so they're all looking good. Everything looks correct. I'm just going to hide my PMI and I'm going to go to the home, click select. Looks like we have a smart part that will update as we change our peg pattern. Let's go again. We change the NX peg count to maybe 4 pegs. Hit enter and that seems to have worked out fine. So it looks like it'll work in that direction. And if I change my NY peg count to 3 and press enter, things don't look so good. And that's because we haven't actually we haven't linked the block depth to the number of pegs in the part. So we need to create a formula to do that too. So I'm just going to change back to 2 for NY peg count. And I'm going to go up here and type in the formula box equals 2 multiplied by 3.9 plus 8 between pegs multiplied by bracket. And now I'm just going to click on the variable NY peg count and type in -1 and close bracket and press enter. And now we see the same happened here. Our value square has changed grey and the lock symbol has disappeared. This is now a driven dimension. It's driven by the variable NY peg count using this formula. All right, so let's see now how things change. If I change NY peg count to maybe 3, our block updates. And we can change it to 4 and we can kind of go mad. You know, we can get 10 in the X, 7 in the Y. We have a pretty smart part. We can do similar on the underside of the part. You'll notice actually we already have part of it done because we acted kind of smart when we created this pattern feature. We didn't just choose the top peg feature. we also chose the bottom cut feature. And that means as we update the pattern, all of those cuts happen under each of the pegs, which is very, very helpful. Makes life a lot easier for us. So I'm going to open up our style palette. I'm going to do a couple of things here. First of all, we change the face of the color of this part just to improve our contrast as we're looking at features. And also our parent feature, I just want to highlight that as well so that we always know where our parent feature is. So I'm going to select that. All right, so I'm going to close the style palette. I'm going to open up our Pathfinder and let's get started. Let me just click, yeah. So protrusion 2 is our parent feature and that's highlighted by the red dot here on that face. All right, so everything in our part looks good up until maybe these mirror features. In the mirror features, we mirrored these two features here onto there and then we mirrored all of these features here onto here. That was fine for a 2x2 block, but it doesn't really scale as we create other features. So we could, I suppose, delete those features or we could reuse them. It's probably less confusing to delete them. So I'll just delete them. And we also have this cylinder feature. I'm not going to worry about that at the moment. So I'm just going to click on protrusion 4 and click on this GoTo button. Now you see this anti-clockwise symbol. We've gone back in time to before protrusion 11, just after we created these two protrusions here in our corner. And now we just want to pattern those. We can use the pattern feature. I go up to home. So I'm going to click on the pattern command. This time we're going to use a pattern type regular, placement type quick pattern. I'm going to change that this time to pattern by sketch. And the selection type feature. So click on a feature is in our prompt bar. I'm going to go down here, click on this rib, and I'm going to click on this tick box to finish the selection. And our sketch is saying create from coincident plane. In our prompt bar, click on a planar face or reference plane. And let's take a look at that. So we can hover over a face to be our sketch plane to define the pattern on. It could be the blue face or it could be the green face of our part. So as I hover over a face, all edges of that face get highlighted with orange, except for a single edge gets highlighted green. And you can see the bottom edge of that face is currently highlighted green. And what that means in Solid Edge is that if we click there, that will be the x-axis of our sketch plane. And it's important to note that the x-axis of a sketch doesn't necessarily have to line up with the x-axis of our base coordinate system. So in this case, our x-axis would be parallel with the y-axis of our base coordinate system. But we can also fine-tune which edge we want to use as our x-axis. So I can press the B key to move the selection of our x-axis clockwise, or the N key. Each time I press it, it moves it one to the next line, moving anti-clockwise. So now we have highlighted an x-axis that is parallel to the x-axis of our base coordinate system. And I'm just going to click on that face to accept that. And now we have a sketch plane for our pattern. We have the number of instances here we want to have in our pattern in the X and Y direction. I'm not too worried about the values of these at the moment. I'm just going to choose 3 for the X, 1 for the Y. And it's looking for a width and a height of our pattern. If I look over here, click for the first point. So let's go down here. We want to define our pattern about the base feature. We want something that's never going to change, and that's going to be our parent feature. And a logical place to select our pattern would be maybe the midpoint of this rib here, or since we always want it to be in line with the peg, we could also choose the center point of the peg here. They always occur together. So maybe I'll just choose that center point and now click for a second point. So you'll notice as I move around, Solid Edge is defining a rectangle to create the pattern around. So if I click on maybe the center of this circle here, that will be fine. But what happens if we change the size of our part? It doesn't necessarily work anymore. So I'm just going to click anywhere that isn't actually defined into a point. And now we have our pattern feature. But you'll notice that the sketch for our pattern is blue. It's not fully constrained. So I'm going to create a smart dimension. For starters, I'm just going to measure where is our pattern located. It's 3.9 millimeters from the edge of the part and 3.9 millimeters from the edge of the part there. And just take a note that both of those dimensions are blue. If I click on it, it shows up that's a driven dimension and this is a driven dimension. And I'm going to click on Smart Dimension again. And this time I'm going to click on this edge and click. And this time Solid Edge created a driving dimension. And I want that to be the same value as here, 3.9 millimeters, and press enter. And do the same again up here and 3.9 millimeters and press enter. And now you see our sketch has turned black. It's a fully defined sketch. That means no matter what happens, Solid Edge will know what to do. It's fully defined. It fully knows how to define this sketch. So I'm going to click on this box to exit the sketch. And now we can just give that pattern a name. So I'm just going to call that pattern Rib X pattern and click on the finish button here. And now if we look at our pattern, it's not quite right. We have 1, 2, 3 little ribs on the pattern, but that's okay. So we can tidy up the rest in the variable table. So we know that we want to have one of these ribs along the X every time we have one of these pegs. So all we really need to do is go to Rib X pattern. We see at the moment we have 3 ribs. And I'm looking at this variable here is 3. So let me just check. If I change that to 4, will the number of ribs update? And there we go. 1, 2, 3, 4 ribs. So it looks like this is the variable that drives this feature in our pattern. So I'm just going to use a formula to drive that value. So I'm going to press equals and go up here to peg pattern. And I'm just going to click on nx peg count. And I'm going to press enter. And now our value for that variable has changed to 10 and it's in a grey box. It's driven by that variable. Oh, I clicked in the wrong box. Okay, so I'm just going to delete that and I'm going to change that to 1, press enter, and I'm going to do it. This is the box I meant. This is 4. Let me just check again. Yeah, so I pressed enter and it moved it down a box and that got me confused. So I'm going to press equals and I'm going to click on nx peg count, press enter, and now our feature has updated. Let's take a look at that. And you see now, yeah, our feature is in line with each peg. Everything seems to line up perfectly. And we can do the same again for the Y pattern. So let's click on the pattern command, rectangular pattern. Again, we're going to go with pattern by sketch. And I'm going to select this feature and just tick this box. We're finished selecting features. Click on a planar face or reference plane. So I'm hovering over a face I want. You can see the green line is the bottom line of the bottom face of our part. It's running parallel to the X-axis. If it wasn't, again, I could use the N or the B buttons, but since it is, I can just click to select that face or for our sketch plane. And now we have click for the first point to define our pattern. I can go down here. Now again, for the pattern, it has an X count of 3 and a Y count of 1. That's something we can change afterwards in the variable table, so I'm not very worried about that value. So I'm just going to define the base point. We could do it again about the center point of this circle, or we could do it about the midpoint of our feature. Doesn't matter because they're both in line with each other. This time let's do it about the midpoint of our feature, and it's looking for the second point for this rectangle. I'm just going to be careful not to click on any specific point on our part. We want a dimension to kind of define that. And now I'm going to use Smart Dimensions, create a dimension from here to here just to figure out what that value is. That's 1.4 millimeters. It's a driven dimension. And from here to here is 3.9. That's a driven dimension as well. And so that's what our driving dimensions should be if we want to keep our part consistent. So I'm going to create a 1.4 dimension from here to here. Type in 1.4, press enter. And from here to here, 3.9. Hit enter. Now our sketch is fully defined. I can click on this box to exit the sketch and we can just give the pattern a name. So I'm going to call this Rib Y pattern 4. Click finish. And now if we look at our pattern, we see here we have one feature here and there's our pattern feature. So I did that totally wrong. I really wasn't thinking. And there's our other pattern feature. So they're going in the wrong direction altogether. But let's just take a look at it in the variable table, and we have Rib Y pattern 4, and it looks like this is the X direction. So let's change that from 3 to 1 and hit enter, and those two patterned instances have disappeared. So now we have a 1 by 1 pattern, which isn't much use to us. And let me just see, we change this value from 1 to 3 and press enter. Now you see we have our parent feature and 2 child features are created. So this is our value to drive the Y occurrences of our pattern. And we can also drive this by a formula. So in the formula box, I'm going to press equals and I'm going to go to peg pattern 1 and click on the variable ny peg count. That's been selected, so I can just press enter and it changes from 3 to 7 and the box has turned grey. And now if we look at the features, they have all lined up with the holes. We just move the variable table out of the way. If we look at the bottom view, we can see now all of our ribs have lined up with those. Everything has worked fine. And more importantly, as we update the part, if we change NX peg count to 12 and NY peg count to maybe 4, press enter, our part changes shape, but the ribs also follow along as we like them. So that's done for two faces on the inside of our part. The other two faces, we haven't done that. Maybe we could do that with a mirror. So let's use the mirror copy feature command. And our prompt bar says select features to be included in the mirror feature. So I'm going to start off by choosing the parent feature here, and I'm going to choose rib X pattern. So that's all of the features along this face of the part. And I'm going to tick this box to finish the selection. And now it's looking for a plane to mirror them around. I'm just going to turn on the reference planes and I'm going to choose the front plane and it's saying mirror copy 3. I'm just going to change the name of that to mirror rib X, press enter. And if we look at our part now, all of the features have been copied across. And we can do the same again for ribs along the Y. So I'm going to click mirror, select feature step, I'm going to choose the parent feature and the rib Y pattern feature from the pathfinder. That's all of those selected. I'm going to tick this little box and it's in the prompt bar, it's saying click on a plane or face or reference plane. So let's do that. This time I'm going to choose the right plane. And you get a preview showing all of the features mirrored. And this time I'm going to choose the name of mirror rib Y and I'm going to click finish. So let's just confirm now that if I change those values, everything updates okay. So I'm going to change NY peg count to 7 and NX peg count to 8. And you see all of our rib features have updated along with the mirrors of them and everything looks okay. So the only feature now for us to do is I'm going to go to protrusion 1 and this is our hollow cylinder and we could do basically the same thing again. So let's just get our variable table out of the way. Protrusion 1, profile 22 and I'm going to edit that profile. And our profile is fully constrained and it looks like all of these constraints are related to the center. So I'm going to window select the center and press the delete key. And now both of the circles have become unconstrained and I'm just going to drag them roughly to our parent feature. It's easy to find because we've colored it red. And again, I want to make them concentric with each other. So I choose the concentric relation, click on the circles, and that's that. And let's just make some measurements here. So that's 3.9. I'm going to make this 3.9 plus 8 divided by 2, enter, that's 7.9. And I'm going to do the same again here, 7.9, enter. Okay, that sketch is now fully constrained, so we can exit that sketch. I'm going to call this hollow cylinder, and our feature has been recreated in the corner of our part, and it's beside our other parent features. It's kind of a nice place to locate it. And for this feature to carry across our part, there will actually be one of these between every 4 pegs. So that will mean there will be one less than the number of pegs in the X direction and one less than the number of pegs in the Y direction. So let's get patterning. Okay, so click on pattern. And again, we're going to use pattern by sketch, selection type feature, and the prompt bar is saying click on a feature. So I'm just going to click on hollow cylinder from the pathfinder and I'm going to tick this little box to accept it. And we move on to selecting a planar face for our pattern. We could again select the bottom face of our part as our planar face, or we could select the blue face as our planar face. And things are a little bit confusing now because Solid Edge seems to be picking up on some of our base reference planes, and it's generally things are a little bit messy at the moment. So just to make it clearer what we're selecting, I'm going to turn off the display of our base reference planes and go back and now hover over the faces of our part. Something you might notice as I hover over the blue face of the part, the green line where our x-axis would be is vertical. It's running parallel to the y-axis. So if we wanted to keep things simple and avoid any kind of confusion in our variable table, we might want to make that x-axis parallel to the x-axis of our base coordinate system. So I could press the N button to move anti-clockwise or the B button to move clockwise. And you can see the selection of line changing as it moves around to the next line if I press B again. So let's go N because it's closer. I go N, N, keep pressing N and press N, 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 N. And there's a respectable length of a line in the direction we want. Oh, we lost it, so let me go again. And I'm just going to click there, and that gives us an x-axis parallel to the x-axis of our base coordinate system. If we go over to the prompt bar, click for the first point. So for the first point of this part, I'm just going to choose the center of this hollow cylinder. Okay, so I'm going to hover over the circle until the centered glyph is selected. And now I click, and now it's saying click for the second point. So I'm going to look for a point that I can click on that isn't actually picking up on a key point. So I'm just going to click here, and let's make smart dimensions now to define that. So we know we can take our reference dimensions here, from here 7.9 millimeters, and from here 7.9 millimeters. These are driven dimensions by the location of our feature, and we want the same for this line here. So we want this to be always 7.9 millimeters from the edge of our part as our part grows and shrinks, and the same here. We want this to be always 7.9 millimeters. So we enter that. Now our sketch has become fully defined. I can click this button to exit the sketch, and Solid Edge is looking for a name for the sketch. So I'm just going to call this hollow cylinder pattern, and I'm going to click finish. And at the moment we only have 2 because I didn't really worry too much about the number of features. It's not something that we want to define from the feature itself. So we're going into the variable table again. And now we have our hollow cylinder pattern. So let's just see if we can create formulae that will always make sense for our part. So I'm going to change this value to 2. Okay, so we know this is the Y value. I'm going to use a formula to change that. So I'm going to press equals, and I'm going to go to peg pattern 1, and I'm going to choose NY peg count, and I'm going to select -1 and press enter. And for this variable here, I'm going to press equals and click NX peg count -1 and press enter. And there is our part fully populated. Between every 4 pegs, we have one of these hollow cylinders, and in line with each of the pegs, we have one of these ridges, and that looks good. And let me just double check now that things are actually okay. So I'm going to choose 10 for our NY peg count, 12 for our NX peg count. There's our feature, and our features on the underside have been updated as well. And you can go crazy with this, but you're probably going to put your computer under pressure. Hopefully you followed along and you've made your own smart part here. In our next video, we're going to look at making our first assembly in Solid Edge. Hopefully see you then. Thank you.